Welcome to another playlist where we talk about how we can work and understand Spring Boot and JUnit. In this playlist, we'll talk about how we can use JUnit and write unit tests for our Spring Boot REST API application. We will do this by learning how JUnit works, what unit tests are, why do we actually need to write unit tests, and what does testing even mean. So we will start with the basics of what testing is in this video and slowly move ahead with basic unit tests, and then we will actually build our REST API and then write unit tests for our REST API. In this playlist, you can expect learning about TDD, which is test driven development, where we understand what that paradigm is, why that is pretty famous in the current software engineering scenario, and what do we actually mean when we say TDD or test driven development. So let's before all of that, let's just understand what testing is and what do we actually mean by testing a software system. So testing the system is an important phase in a software development lifecycle, the SDLC. Testing promotes code reliability, robustness, and ensures high quality software delivered to clients if implemented correctly. So testing has been given more importance since TDD has become a prominent process in developing software. Now, test-driven development entails converting requirements into test cases and using these test cases to gatekeep code quality. Now, code will be considered unacceptable if it fails any of the test cases declared in a system. And the more test cases we cover, the better the product becomes. The code base is lengthened considerably, but it reinforces the fact that the system meets the given requirements. Now, REST APIs are rigorously tested during integration testing. However, a good developer should test REST endpoints even before integration in the unit tests. Now, we have these two terms called as REST integration testing, unit testing. So let's understand what all of them mean. So before that, let's talk about the purpose of software tests. So a software test is a piece of software which executes another piece of software, asserting that it is behaving in a way that we want to. With software tests, we ensure that certain parts of our software work as expected. These tests are typically executed via the build system and therefore help developers avoid breaking existing code during development activities. Running tests automatically helps to identify software regressions introduced by changes in the source code. Having a high test coverage of your code, basically testing all possible edge cases in your code, allows you to continue developing features without having to perform lots of manual tests. Now, you should write software tests for the critical and complex parts of your application. If you introduce new features, a solid test suite also protects you against regression in existing code. Now, some developers believe that every statement in your code should be tested, but in general, it is safe to ignore trivial code. So, if you have a simple if-else statement or a for loop statement which you are confident about what it does, then you don't have to write a test or test whether it's working or not, right? Because you already know how it works behind the scenes. So, for example, it is typically useless to write tests for getter and setter methods, which simply assign values to fields. Writing tests for these statements is time consuming and actually pointless, as you would be testing the JVM. The JVM already has test cases for this. So if you're developing something in Java, it is safe to assume that a field assignment and all of that works properly. So now let's talk about some testing terminology. The code which is tested is typically called the code under test. If you're testing an application, then it is called application under test. A test fixture is a fixed state of a set of objects which are used as a baseline for running tests. Another way to describe this is called as a test precondition. Now, I'm not showing all of this in the video because I'll be putting the links in the description and they have a much comprehensive way of understanding these definitions. But before we actually, jump ahead with the practical coding part, we need to understand what these are and talk about them a little, right? So check out the description for the links where you can understand them in depth, theoretical part. And this video is here to make you understand how we implement everything. So now let's talk about the different terminologies: unit testing, integration testing, performance testing. So now a unit test is a piece of code written by a developer that executes a specific functionality in the code to be tested and asserts a certain behavior or state. The percentage of code which is tested by unit tests is typically called test coverage. Again, the percentage of code which is tested by unit tests is typically called code coverage. A unit test targets a small unit of code, let's say a method or a class. External dependency should be removed from unit tests. So if your particular function is dependent on some external class, or taking something from external libraries or modules, then you can ignore them and only test what that particular function does. Now, how do we do this? We do this with the depend. We do the replacement of external dependencies with a test implementation or a mock object created by the test framework. So JUnit provides, and other libraries provide us with a way to mock those external dependencies. So now, if you want to test the complex user interfaces or how two different software components are interacting with each other, for this you need to develop an integration test which checks the integration of these components. Now, an integration test aims to test the behavior of a component or the integration between a set of components. The term functional test is sometimes used as a synonym for integration test. So you want to test the functionality between two components. Now, integration tests check that the whole system works as intended. Therefore, they are reducing the need for intensive manual tests. So, if I want to test an API or check whether an API is talking to another API, I can run both the APIs in a testing environment and then manually do a post request and check whether something happened or not. Or I could do an integration test. It automatically does this for me, saving me time. And it's easy. It's more work for the system and less for the human. Now, the last thing which we talk about is performance tests. So performance tests are used to benchmark software components repeatedly. The purpose is to ensure that the code under test runs fast enough even if it's under high load. Now, in this playlist, we will strictly be focusing on unit tests, which is something a developer needs to write to make sure that the code which they write is working properly before they send it to production. And a unit test is something which I feel is very important for a new software engineer who has just graduated from college, or even for an intern who's working at a big corporation. Unit tests ensure that your code is correct and it is covering all possible test cases. So this particular playlist will be about developing a REST application and writing unit tests for those APIs which we develop. So there are two ways of doing this. One is to first implement our REST API and then write unit tests. The second is the TDD approach, where we first write our test and then we use those tests to build our REST application. And in this playlist, we will be seeing both of those approaches as we go. Now, before we jump on to creating our project, let's just talk about what is behavior versus state testing. Now, a test is a behavior test if it checks if certain methods were called with correct input parameters. A behavior test does not validate the result of a method call. So it only checks if the input parameters were correct or not. State testing is all about validating the result. And behavior testing is about testing the behavior of application under test. Now, if you're testing algorithms or system functionality, in most cases you want to test the state and not the interactions. A typical test setup uses mocks to abstract the interactions so that other classes are not dependent on this. And after that, you test the state or the behavior as you need. So this is some simple theoretical information that we need to know about why we do testing, the reason for why we need to understand what are the different terminologies, etc., etc. Now, for this tutorial, we are going to create a project, a Spring Boot Maven project, and then we are going to install some dependencies and make sure that our project is up and running for further implementations. So let's go ahead and create a new project. This is what you get when you create a new project. Go to next. Let's give it a name. Let's give it JUnit REST API application, and let's click finish. Now this will give us our application. So Let's wait for a minute for it to be fully loaded. Now the best part about writing tests using IntelliJ and using a main project is that we automatically have a testing folder where we put in all of our tests. So now that we have our repository ready, let's go into SRC, go to main. Here we have Java and resources. But if you see in the SRC, we have test as well. And inside test, we just have a Java folder. So nothing in it right now, but all of our tests will be inside the Java folder, and it will be inside the test folder, which encapsulates the Java folder. So before we jump into all of that, let's first include all the dependencies that we need for this project, so that we are good to go. So the first thing that we need is our parent. So the parent is going to be having a group ID, which is going to be org.springframework.java framework dot boot, and we have the artifact ID as well, Spring Boot startup parent, and the version is going to be 2.2. Oops, not here. 2.2.2 release. So this will basically have all the typical things that we need for our Spring Boot REST API and get started. The next thing that we need are dependencies. So we need a bunch of dependencies, and we'll talk about what all of them are. So dependencies, and now let's add in our dependencies. Before that, let's just add in our build plugin, so that we want Maven to fetch all of our dependencies. So let's quickly add that here. So this basically tells Maven to get our dependencies from the Maven repository and put them inside our um, local dependencies, Maven dependencies folder. Okay, now what do we need? So first we need some starter repositories. So let's quickly get them inside here. So we need Spring Boot Starter Web because it is going to be a REST application. The next thing is Spring Boot Starter Test. It has simple things that we need for our testing environment. Next, we need Lombok. So this is basically a very handy um, dependency which will help us with a lot of annotations and help us with everything which we need for that. And we need a couple of more. So let's quickly add them and then talk about them. So first is Apache Derby. So we, since the main intention of this playlist is going to be testing our code, we want to minimize our dependency on external databases. So Apache Derby is an in-memory database which will be up and running just as we, give this dependency, and that's all we need to run an in-memory database. Just add this dependency, and we are good to go. And the next thing which we need is Spring Boot Starter Data JPA to have our tables ready. And Mockito is something which I want to save up for the upcoming videos, because this will require a video of its own. So now that we have all of our dependencies and everything ready, let's quickly have our API runner. So let's go inside SRC, main Java. Let's have a package. So let's say com.rest.application, and inside this we can do REST API runner, and this will be pretty straightforward and boilerplate code. So before we do that, let's quickly refresh our Maven dependencies and add all the dependencies to our project. Should take a minute or so, and I think we're good to go. Now we need to do another Spring Boot application, and we need to have a main method. So public static void main string args, and here we need to run or start our Spring application dot run, and the class which we are running is REST API runner dot class, and we pass in the args we get from the method. Okay, so now we have our simple project ready, and let's run it to make sure that it's running properly. Takes about some seconds to build up all the classes and everything else. Yep, should be up. Hopefully no errors, because we have been doing this for quite a long time. Yep, everything looks good. If you see the data source, you'll see Hikari and everything else, because we're using Apache Derby. So we already have our GPA and everything else, installed, and we literally have a database up and running with our Tomcat server. So yeah, we have everything up and running to start implementing our unit tests, and that is all for this video. In the next video, we will go through some basic JUnit examples, and then quickly move on to building unit tests for our REST API application. So thank you for watching, and I'll see you in the next video. In the previous video, we had talked about what testing is, why do we actually need to write tests for our software. We talked about the theoretical bits, where we talked about the terminology. We talked about what is unit testing, what is performance testing, what is integration testing. We also talked about why we need to write tests inside our applications, and we also had developed our simple REST API runner, where we had our dependencies installed, and also had some simple REST API up and running. In this video, we are going to jump inside JUnit and see how JUnit works. So JUnit is a popular unit testing framework in the Java ecosystem, and we'll be using JUnit 5. And let's see how all of this works. So first, as I said, we need to have some conventions. So we need to understand some conventions when we are writing tests. We need to write our tests inside the test folder inside Java, and here you need to have a Java class which will basically have a name. Now, when you are writing a test class, the class name must end with test, so that we know that it's a test class. So here, let's just say JUnit example test, and now we have a class ready to be tested. Now let's basically first see how everything works here. So all we have to do is do iterate test, and let's just say void demo test method. And here what we can do is assert true and just do true. And let's import assert true now. So more actions, import static method from JUnit. Okay, so now we have a simple test which basically is which passes no matter what happens. Now let's just run this test and see how it looks like. So when you run this class, we want to see what happens, right? We want to see what are we actually doing behind the scenes, or what is happening, and how do we actually check whether the test passed or the test failed. So this one has to pass by default, because we are asserting true and it is true. So our test failed, and now we need to see why it failed. So it should be public. So we'll do a public void test method, and let's run it again. So now when you slowly see, you'll slowly understand how it is working. So we wrote a test, the test failed, and we exactly knew what was wrong with the test. There was no public, and the test has to be public. No, that way we can use our test to understand what is wrong with our code. So now, as you can see, we have a part. No, we pass a test, and when we pass a test, we get nothing in the console. That tells us that everything was running smoothly, and we don't have to worry about anything that is happening. Okay, great. Now let's actually write some good tests. Not something like this. Let's go inside our application, create a new class. Let's say calculator. Simple examples because we're just learning how unit testing works. So a very simple example, a calculator. This will have a method, so public int multiply. We are multiplying two numbers, and now we just return a b. Now we this is a very simple example, and you might think that this is not worthy enough for a test, because what are we doing? We're just multiplying two numbers. But let's just start with simple examples to understand how the framework is, and what the framework does, and then we will add some real life examples with the REST API application. So bear with me for these tests. They look very simple, I understand, but we will slowly go inside the good ones, the good tests. Okay, so when you have a class, we need to write tests for that class. So let's go inside Java and do another one. So we do calculator test, and this class will have all of our tests for the calculator class. Now we need to test the calculator class, so we need that inside our calculator. Now we haven't initialized this yet, right? So we need to initialize this before we we go inside our tests, right? So here, as you can see, this is a test. Our test will be methods. So before we go inside this method, we want our calculator class to be initialized. So JUnit provides you with an annotation called as before each. So before each test that we write, do this, and this is going to be a void, a setup method. So let's set up our testing environment, and all we do is we do calculator equal to new calculator, and that's it. We have our calculator class initialized for our testing environment. Now we can start with our tests. So first, we need to do a simple test, right? A simple test that we know. So let's just write test. Let's import the class from JUnit, and this will be void test multiply. A simple test, nothing complicated here, pretty straightforward. And all we do is assert equals, and our output will be 20. And when we do a calculator dot multiply, when we multiply 4 and 5, we get the output as 20. Let's again import the static methods. Okay, so as you can see, we are doing a calculator multiply from 4 and 5, and we expect 20 to be the answer, and we do an equals test here. Pretty simple, straightforward. Let's make this public because we don't want the same errors again. So public. Yep. So a pretty simple test. Let's see what happens here, and we'll do a run for our test. You can also run an individual test, but we'll just run the entire class because why not? So the test failed because we got a null pointer exception, and now let's see why that is. So let's go ahead and see what was wrong again. So at line 18, so now calculator was null, and we need to see why that was. So let's skip this for now, and we'll do calculator equal to new calculator here, and then we can test it again. And the test is passed. So before each had some problems there, but we can worry about that later when we're done. But we just want to show you how how testing something looks like. And here we saw that clearly with our calculator multiply test. Now let's do this again. Now we'll do the same thing, but we want to test with a different number. So if we do our test multiply different parameters, and let's say we want 5 into 5, which is going to be 25. Or so yeah, let's test this now. Let's write two tests and see what happens. And both the tests pass. Pretty straightforward, nothing magical happening here. And what you should notice here is that nothing is changing here, only the values are changing, right? So we don't need a different test scenario or test case for this. This can basically be inside the same test. So we have an assert equal, and we do another assert equal, and here we do 5 comma 5, and the expected is going to be 25. Great. Let's run the test again. So let's remove breakpoints for now and just run the test. Yeah, now you see what happens. Now that we have done this, let's actually see what happens when we fail a test. So now let's just say we expect this to be 10 because we don't know what 4 into 5 is. And let's say we just put this by mistake, or some other developer by mistake had changed the value here, and he doesn't know anything about it. But now if he does that, it messes up the test. And how does he know that? So when the continuous integration deployment pipeline runs our test, the build system, it will fail this particular test, and we will see how that is. So this is how it looks like. The test failed. The expected was 10, and what it found was 20 by the value, so it failed. And that is how we know that our tests are passing or they are failing. Now all we have to do here is change it to 20, and we will be back with our tests. And yeah, we are back to it. Now, we haven't tested our code out properly, right? We have done an A into B, but what if you do an A divided by B? So if we have another method here. So let's just say divide, and we do A by B. Now, how does that work? How does that happen? And let's see how this works as well. So now let's write another test. So we can call this test divide, spell it correctly. Does the same thing, and all we do is divide, and let's say divide 4 by 2, and the expected is 2. Let's run the test now. And the test passed. Now this would make you seem that our calculator is pretty well functioning. It is doing what it has to do. It is dividing and multiplying. But what happens when you divide by 0? Because that is an edge case that we need to understand and we need to handle. So let's just see what happens here. So if somebody application is using a calculator and he divides by 0, we need to tell him something. We need to give him something. So here we say test failed and arithmetic divided by 0. Now we can write test cases where we handle this, but we will look into that in the upcoming videos with the REST applications. So this video was basically an introduction of how the JUnit framework is, and some big examples where we understand how JUnit works. And from the next video, we are going to start building our REST API application, and then start writing unit tests for it. So thank you for watching, and I'll see you in the next video. So in the previous videos, we talked about what we are going to build, which is going to be a REST API, and then we are going to write unit tests for that REST API. We will also be talking about the TDD approach, the test-driven development approach, where we first write our tests and then we build our API based on those tests. So we will be doing that for one of the methods of our REST API or one of our APIs. And in this video, we will actually build our REST API so that we can, once it's ready, we can start writing the unit tests for it. So just a quick recap of what we had done in the previous videos. So we had talked about very simple examples of JUnit, how JUnit works. We also had this calculator class, which we talked about, where we had simple methods, multiply, divide. We had also made a simple calculated test class, and we talked about the guidelines for writing good tests. So it should end with a test name, and how we can actually assert that the output which we are expecting from that method is what we actually get. So this is how we talked about JUnit, how it works. We talked about assert equals. What we also talked about what happens when a test is not passed. So here you cannot divide by zero, so it throws an exception. But when you run this, and if you had not tested your code, you would not know that 4 divided by 0 could give you an exception. So you write a test to check what happens when you divide 4 by 0. And we run the application or run the tests, and then we find out that the test has failed, and we also get the reason why it has failed. So in these ways, tests are very handy for your application to make sure that you don't leave out any test cases or edge cases for your application where it can break or cause some complications in your code. Okay, now let's go ahead and create our domain and persistence layers for our REST API application, and then we can start writing unit tests for them. So in this video, let's start. Now we can remove calculator for now, or let's just remove it because it was an example. We can also remove the calculated test class because we don't need it now. We understand how JUnit works normally. The next thing that we are going to add is a domain layer. So basically an entity which we will be using throughout our videos, and which we'll be using for our REST API application. So somewhere where we can store our data in a class, right? So let's make a library, a library or a book management system. So we'll have a book class, and here we will be adding everything. So uh, now we need to add some entities for our book record. So we will be using some annotations such as entity, the table annotation, to make sure that the class is pointing to the right table. Aside from these two annotations, we will be including Lombok utility annotation. So data, all args, constructor, and builder. So we won't be needing to declare any getters and setter and constructors, as Lombok already does that for you. The string and integer fields are annotated with non-null to prevent them from having a null or an empty value for validation purposes. So let's quickly implement this and see how this looks like. So what we do is first have annotations here. So we have entity. Next we have table, and let's give the table a name. So name book record. The next thing that we need is data. Next is our constructor and all our constructor. And the last thing that we need is builder. Okay, so now we have our annotations ready. Let's start with what the book will have. So each book will have a unique ID. So we have the ID. Next thing that it will have is generated value, and the strategy is going to be generation type auto. The next thing that it will have is a private long book ID. The next thing that the book will have is a name, so non null, and private string name. name of the book. The next thing which we want is private string, a summary of what the book is about. And lastly, we need private int rating. So this will be out of 5. The rating will be out of 5, and we just have a few other things to note down, which is the book ID, name, summary, and rating. So this will be our record or a domain layer, which we can use to actually run our application and handle the book create, update, delete APIs for the book record. Now, we don't need to actually connect it to an external database because we are using Apache Derby, which is an in-memory database which is handled at runtime. So once we run our application, we don't have to worry about initializing anything. We can directly just start our CRUD applications, and Derby will handle the database uh, things for us. So now that we have our um, book record ready, the next thing that we need to do is have a book repository. So let's quickly see how we can work with that. So the next step is to create a JPA repository to provide methods to easily retrieve and manipulate book records in the database without the hassle of manual implementation, right? We don't want to, we are only looking to have some simple CRUD methods on top of our book, and we will be focusing more on the unit tests part for this. So for that, let's create a new class, not a class, but an interface. A new class, and let's just call it book repository. And this need not be a class. This can be an interface, and all it does is it extends JPA repository, and it has the book and the ID, which is along. And now with this, we have our book repository ready, and we can actually do create, update, delete with our repository, and it will help us understand how all of this works. So now that we have our book and our repository ready, let's just see what we can, how we can work with it. So the next thing and the last thing that we need is our book controller class. So go inside this, go to new book controller, and this will handle all the APIs for our class. And let's just quickly annotate this with our endpoint. So res controller. The next thing that we need is request mapping, and value is equal to slash book. So all of the endpoints start with slash book, and then we have our way in with it. So now we need to inject the book repository bean inside our controller so that we can do create, update, delete with it. We are not making a book service. We are just going with a book repository to handle our CRUD applications because we want to focus more on the unit test side, which we'll come to in a bit. But for now, we'll just create a boilerplate CRUD application. So do an auto wired, and this will be book repository, and now with the help of this, we can actually start using our book repository and our book controller and start making all the changes that we need to. So for this video, this is all I have, a very quick implementation of the domain and persistence layers for our REST API application. We had created the book.java, which basically had all the fields and attributes for our book, which will include the book ID, name, summary, and rating. We also created a book repository which extends the JPA repository and gives us out of the box methods to use on top of our book data. And we will be using the book repository inside our book controller class using the auto wiring injection method. And then we can start creating our get, put, post, delete mappings and our endpoints, which can later help us writing unit tests. So here we will be only implementing put, post, and get for our methods. we will write tests for those methods, and then at a later stage we will be using TDD, test driven development, to actually implement the delete method. So before we actually write the logic for our delete method, we will be writing tests for our delete method, and then as we try to pass each test, our we will see how we are developing that particular method using TDD, and we'll see how we'll compare how both the methods are and which one is suitable for you or which one your organization uses, and based on that you can worry about what to handle, what not to handle. So that's it for this video. We talked about the domain and persistence layers. In the next video, we will finish up our book API, and we will implement our endpoints, and then we can quickly jump ahead with the JUnit unit tests for our REST API application to make sure that these applications, these methods are actually running properly and they are passing all the tests that it needs to pass. For this tutorial, you will be having some homework as well. So once we have implemented the simple unit tests, you will be getting some homework. So stay tuned for that as well. And thank you for watching. I'll see you in the next video. In this video, we will implement the business layer of our REST API so that we can then start with the testing process and understand how we can test our REST API application. And let's just go over a quick summary of what we have learned in the previous videos. So in the first video, we had talked about what we'll be building, which is unit testing our REST API application. We talked about the importance of software testing in the software development lifecycle. We have also talked about what JUnit is in the second video, and also we saw some simple examples of JUnit. One is here, where we see how we can prepare a test class, use the test annotations, and then basically write our tests for our application. In the third video, we implemented the domain and persistence layers for our application, where we had implemented a book record and also had a book repository, which extended the GPA repository class. Now, in this video, let's start implementing our endpoints and see how that works out. So first, we need to do a simple get mapping. So let's start with a get mapping, and we just get all the books. So we'll do a public list of book, and this will be get all book records. Let's make sure R is capital, and let's import the class. And this will be return book repository dot find all. Pretty straightforward, as you can see. The main reason why we are using the JPA repository is because we get out of the box functions which can automatically help us with our REST API database implementations. So this is the get all book records. The next is a get book by ID. So we'll do a get mapping again, but this time the value which we need is going to be the book ID, and once we have the book ID, we can return it back to the public or the client. So we are going to return a single book. So get book by ID. We will be having a path variable, and this path variable is going to be having a value called as book ID, which is going to be a long book ID. And now let's quickly implement our book repository method. So we return book repository dot find by ID, and we just pass in the book ID into it. So as you can see, pretty straightforward. Let me simplify this a little bit so that it's easier to read. Pretty straightforward, nothing to worry about here. Return an optional. So this is going to be an optional book ID. So let's take care of that. Shouldn't be a big issue. All you can do is just do a get. So dot get, and that should be helpful. Okay. So So now we need it to be an optional, but we can work about this later. In fact, we will be finding out all of this issues in our unit test once this breaks. So wait for that. Let's finish implementing our CRUD API. The next thing that we need is going to be the post mapping. So at the rate post mapping, and we are going to create a book record. So we'll do public book create book record, and now this is going to be coming in from the request body, and we have to make sure that it is a valid book record, and this is going to be a book record. And now we return book repository, not book record, book repository dot save, and what we are saving is a book record. Now this will create and add the book as a value inside our tables, and we will be having that book stored. We did not have to implement or write any native SQL queries for this. The Apache Derby in-memory database takes care of all of this with the JP repository interface that we extended, and we can only focus on our business layer and the business logic, which is to create, update, and find our books. Now, the last but not the least inside our application is going to be updating the book record. So this is going to be a lengthier code. So let's start with it. So let's do a put mapping public book update book record. This will also have a request body. So request body. This will also need to be valid. It will be a book called as a book record. Now let's actually make this a bit better than our create book record implementation. So first we do a check to see if the book exists or not before we get it. So what we do is if book record is equal to null, or book record dot get book ID is equal to null, then we can't really get the book back. So what we can do, we can throw new not found exception and just say book record or ID must not be null, and that's it for now. Let's see, we add the exception, no problem. Next we then do get. So we do an optional book, I'm sorry about the dog. We get an optional book which is equal to book repository dot find by ID, and we do a book record dot get book ID. Now we have an optional book. Now let's check if the book is actually present or not. So let's do a check if optional book dot is present, then we are good to go. But we want to do a check, so we'll do if not present, then what do we do? So we throw new not found exception, which will basically say that book with ID book record dot get book ID does not exist. Sorry. And now once we have come till here, we definitely know that the book does exist. So all you have to do is go book existing book record is going to be optional book dot get, and now we know for sure that the book exists, and all we have to do is update its attributes. So we do set, the book ID cannot change, so set name, and we do book record dot get name. Next thing that we will be doing is set summary to a book record dot get summary, and last but not the least is going to be ratings. Existing book record dot set rating, which is going to be book record dot get rating. And this way we have our book record done. All we have to do is save it again. So we do a return book repository dot save, and we do existing book record. Now we have updated the book record. We have everything here. So we have checked whether the book exists or not. We did a check to the database and make sure that the book is valid. Once we have the book, we had updated it and everything was looking good. So now we have a good API ready, a well-written API ready, where it has all the basic requirements that we need for writing our unit tests, which we'll start in the next video. So here, as you can see, we have our book record, we have our book repository, and the controller includes the book repository, get all book records, get book by ID, create, and update. Delete, we will be writing. So let's just do what to do. Write delete end point using TDD method. So this will help us and remind us that we need to write another method called as delete, and we'll be doing that using the TDD method and see how that works. Let's quickly build our application and make sure that everything is working properly without any errors, so that we can then start with our unit tests. And the best part about this is that writing unit tests is that I don't need to check whether my application is working or not with Postman or any other API tool. All I have to do is write unit tests, and if my unit tests are passing, then the book controller and the book API is working perfectly. And if it's not passing, if it's failing, then I know what I need to work on. So this we can work on. So in the next video, some Derby errors which we can definitely solve. But for now, we have our API up and running, and in the next video we will start with understanding how to write unit tests for our REST API application. So thank you for watching, and make sure you go through the links in the description below, which talk about how JUnit works, talks about how we can test REST API applications, and I'll catch you in the next video. In the previous videos, we had built our REST API, we had built the domain and persistence layers for our application. We also had created the business layer for our application, and we did that using the book record, which had the entity table annotations and also the fields. We also created an interface called as book repository, which extended the JPA repository, and it basically helped us with out of the box methods for CRUD applications on our API. Last was the book controller, which we had implemented in the previous video, where we had implemented API endpoints such as get all books, get book ID, post mapping, put mapping, and we will be implementing the delete endpoint in the upcoming videos using the TDD method. Now, from this video, let's actually start doing the unit tests or writing the unit tests for our applications and see how they look like, how they work, and so on and so forth. So we will be writing a unit test for the book controller to check whether these methods are working properly or not, which we had implemented. So we need to test the method, all these methods. So get all book records, book by ID, create book record, update, and also delete whenever we write it. So to do this, first we need to go inside test Java and create a test class. So we do new Java class and we call this book controller test, as we're unit testing the book controller class. And inside this now we need to add a lot of things. And before we do that, let's talk about something called as Mockito, which we will be using for our application. So, to give you some context for why we are going to use Mockito, now we just need to test this, right? We just need to test get book by ID, and it should return us a book. We should test that this method is working, and every other external uh, API in that method is not something that we need to test. We can write tests for the book repository, but mainly we are testing whether the methods work and if it's returning everything properly as intended. So we don't really need to always call the book repository whenever we are writing tests for the controller, because the point of writing the test for the controller is to test the controller and not the repository. So what we need to do is find a way to actually mirror the methods given by the book repository, or mock them, so that we always know what we get back from the book repository and it is not dependent on an external class such as the book repository class here. So for that, to mock the methods and what we return from the book repository, we use a framework called as Mockito. So now let's talk about Mockito for some time. Mockito is a popular open source framework for mocking objects in software tests. Using Mockito greatly simplifies the development of tests for classes with external dependencies. Now, a mock object is a dummy implementation for an interface or a class, in this case, the book repository. It allows to define the output of certain method calls. They typically record the interaction with the system, and the tests can validate that. Now, let's see how it works. So here is a very good website which helps understand how it works. So first, we mock dependencies for the class under test. So we will be mocking the book repository. We execute code in the class under test that we do in our testing class, and we validate if the code executed is as expected as we wanted it from uh, the test. So for those reasons, we will be using Mockito. And now let's understand how Mockito works inside our application and inside book controller test. So let's go ahead and start implementing it. Before we do that, let's quickly set up our REST API properly before we end up with that, because we saw some errors in the previous video when we were running the application. So let's quickly clear them out. So we need application dot properties file inside our resources folder, and all we need to do is just have a single line which updates Apache Derby automatically, so that we don't have to worry about those values later on. And yeah, once we have this, our application should be up and running smoothly. So let's test it right now. Let's run the application and make sure that the application is running pretty smoothly without any issues. Just wait for a second and make sure that the application is running smoothly before we write our tests. We have the console up, and let's quickly see whether everything is running properly or not without any errors. So far so good. We have our database being registered. Everything is looking good. Start completed. So the database driver is ready. JPA is being initialized, and Tomcat web server is running, and as you can see, no errors, and we are good to go with our API. Okay, awesome. So now that we have our API complete and up and running, we need to start using, writing our tests. So before we actually write our tests, we need to add some annotations to make sure it's test ready. So first we need to do is do a run with, and we'll be running with Mockito JUnit runner. So this will ensure that we are only using Mockito to run our class, nothing else. And make sure that it doesn't have the web server up before, because we just want to test the methods inside it, not the web server. The next thing which we need to do is have something called as mock MVC, and we need a mock MVC object here. We will initialize this before, but this is something which we need. The second thing which we need is an object mapper. So we want to convert a JSON to a string and vice versa, because when we do a post request, we want to send the JSON as a string. So let's quickly do that. So we do an object mapper, equal to new object mapper, and next we want an object writer, object mapper dot writer. So now we have our object writer ready, and we can use this for all the classes, but for now we are only doing it globally. Not recommended, but should suffice for this tutorial, because we want to focus more on the unit test part and less on the functionality of how everything else works. So let's focus on unit test now. Now let's see how do we mock the book repository, because we don't want to call this every single time we run our tests. So we can do that by the mock annotation class by Mockito. All you have to do is mock what? Mock the book repository, and now we have a mock ready for our controller test called from book repository. And the class which is going to accept the mocks is going to be the one where we inject it. So we inject the mocks inside our book controller class, and this basically tells us that so the book controller will be accepting the book repository as a mock inside it. So we call it as inject mocks. Next, let's create some test data. So book record 1, and let's quickly import the book class, and this will be new book, and let's quickly give it the name. So let's say Atomic Habits, the summary, how to build better habits, and a rating would say 5 for this book. Next, let's create some other records. So record 2, new book, give it an ID. Name can be thinking fast and slow. Summary can be how to create good mental models about thinking, and give it a rating as 4. The last book that we can add is my favorite book, so let's add this quickly. It will be new book CL and grokking algorithms, learn algorithms the fun way, and this is going to be a hands down 5. Spell algorithms correctly if you're using it. And we have 3 books ready. We have our mock, we have our book controller, and all we have to do now is set up our class. So let's do that. Let's quickly set up our test class. So we have this annotation called as before. This will run the method which we are going to implement before every single test. So before every single test, what we need to do is we need to set up our class, and we want to set up Mockito first. So what we do is we do Mockito annotations. So Mockito annotations dot init mocks, and we do this. So this basically this piece of code basically initializes Mockito inside our class, a boilerplate code. And the next thing which we need to do is initialize our mock MVC. So we'll do it by mock MVC builder dot standalone setup, and we want the setup only for the book controller class, and we do a build on it. This ensures that we are using Mockito and mock MVC for our book controller class, and it will not spin up any Tomcat web server, and it will mock our book repository when we are using it. So in this way, we understand how Mockito works, and we have our test class ready for some tests. And now in the next upcoming videos, let's start writing tests for our book controller class for each and every method that we have implemented. So thank you for watching, and I'll see you in the next video. In the previous videos, we had talked about what unit testing is, why is it required for a software development lifecycle, and we then talked about what we'll be making, which is writing unit tests for our REST API application. Then we moved further on about how to actually create our REST API application. We had created a very simple, very straightforward library management application where we had a book record, and we had a book controller which basically did CRUD applications on our book record. And we haven't actually implemented the delete endpoint yet, which we will be doing later in the next upcoming videos, where we use the TDD approach, the test driven development approach, to actually write our delete endpoint. For this video, we will be doing and finally implementing our unit tests. We will start with our two get endpoint unit tests. So we have these two get endpoints, get all book records and get book by ID. We will be writing our unit tests for them, and we'll see how that goes. But before that, let's just quickly go through what we have done in the previous video, which was about Mockito, and what does mocking mean. So mocking is basically a way to mock all the external or hide our implementation details for external services for that particular class. So for the book controller, we wanted to mock the results and the values which we put inside the book repository, and we only wanted to work or unit test our book controller, and especially only these two particular methods for now for this video. So we will be mocking the book repository and only checking if book records and book ID works fine. And for that, let's start writing our tests. So as we have noticed inside our JUnit example test here, we need to have a test annotation on top of our method. So let's have a test annotation. Next, we need it to be a method. So let's have public void, and this is going to be get all records, and this is going to be success. So this is going to be a test where for a right input we get the right expected output. So we will be adding up all of this inside our application book records 1 2 3, and then we will get back 1 2 3 as our successful output. So let's do this. Let's quickly say let's throw the exception, because it will throw an exception, and let's try implementing it. So first thing which we need to do here is we need to have a list of our book records, right? So we have 3 book records, but they are 3 different book objects. We need to have a way to have them in a list, because a list is what we return here. So we need to have a list of books, right? So first let's create the list of books. So pretty straightforward, list book, and this is going to be records. Will be a new array list, and inside the array list we have arrays dot as list, and inside that we can have records. So we can have record 1, record 2, and record 3. So now we have the records which we which should be the intended output we get, or the intended return value for our get all book records method. So this should give us out a list, and the list is something which we have culminated here. So this is what we expect back from our method if it's rightly implemented. The next thing is to mock our book repository, right? We want to mock and fake our results using the records list. So here what we do is use mockito.when. So when we do a call to book repositories find all, then return. So as you can see, it's pretty easy to understand how they work. Then return records. Pretty straightforward, pretty easy to read that when we call find all, return records, and that is what we are doing here. So the get all book records is basically calling book repository find all, and we are mocking this method to get back our records list of books. Now we need to perform uh, an emulation of the get a get request, and this is where we use mock MVC, which helps us perform that. So we make a request builder. So this is how it will be looking like. So mock MVC request builders dot get, and here it is slash book. That is the endpoint which we are targeting. Next, we want the content type to be media type application JSON. So we want the content to be a JSON. Next is what we need to have inside. So here what we do is basically have a request built. So we have a request built, and now we do an expect. So this particular piece of code will build a get request using a mock, and the get request contains two things. It contains the endpoint, which is slash book, and it contains the content type, which is going to be in the form of a JSON. Now once we make the get request, what do we expect back, right? Because we want to know exactly what we are going to expect. The first thing that we expect is a status dot is okay. So this basically tells us that when we do a get request to get all records here, we get a 200 status, and everything is okay. The next thing to expect is an expect, and here we expect, let's say that since it is 3 records, we want the size of the return list to also be 3. So how do we do that? We do that by mock mv result matches dot json path, and in the json path we have the expression dollar, which basically says start, check the entire json, and check if it has size 3. So this is a very interesting way of writing or checking whether the JSON is actually, the JSON path from the beginning have the size 3. The next thing that we need to check is check a value randomly inside our record. So until here, we know that if the test is running successfully, we will know that we are hitting slash book with the content as JSON. We get back a 200 result. The result which we get back has 3 records in it, and one another thing which you can check to make sure that the records are correct is randomly check the value of a record. So we do and expect, and here what we can do is we can do JSON path expression. So this is going to be $2 dot name. So go to the third record and get me the name. Is how this we parse this JSON, and the value here is going to be exactly what we have here. So let's copy this and paste it here and put our semicolon, and not here, sorry, my bad. Okay, no, it's going to be here. Yep, looks good. So in the last line 64, we tell that we expect so it's 0 indexed, the third object's name to be glocking algorithm, because that is what we intend inside our list of books as records. So when we run this, and if the test passes, then we know that get all book records is working perfectly fine, and I don't even have to run my application and check it on, check manually on Postman or some other API tool to make sure that it is running properly. This is completely automated, and whenever we run this, it will automatically tell us whether the endpoint is working fine or not. So let's go ahead and run this test, and let's see whether our test passes or not, and we will know whether the method that we implemented is a correct method or not. So now it takes some time, a couple of seconds for the test to run. It is faster compared to running a proper, Spring Boot application. So as you can see, it just took us 9 seconds to get the test right. It took 9 seconds because my laptop is slow and it takes some time to things to actually get up. But as you can see inside, the debug info here, you can see we do a get with no parameters. That means get all, and using application JSON, and we are writing this, and we are evaluating the path. The path is okay, it is completed 200, okay, and this is how we actually understand that we are simulating or mocking a REST API get request. And this is basically how we write our get endpoint. And now the next thing which we need to do is do it for get book by ID. But we will do that in the next video. Let me again reiterate on what we had implemented in this video. We had talked about get all records success, which was for this get all book records, and we expect it to be a success, which we did get it. By success, I mean that it should be a 200 status code where the status is okay. All of this is provided by Hamcrest and the testing framework by Spring Boot, so we don't have to worry about how to implement it. We just focus on the business testing part of it. We check whether the JSON returned had three objects, record 1, 2, 3, and we also check whether the last record's name was grokking algorithms. Now, you don't have to stick to the last one. You can have random tests here. So you can have another random test. For example, let me show you another one. So we do a control D, and here instead of 2, let's do 1, and 1 is going to be thinking fast and slow, and we should get 1's value as thinking fast and slow. And now we can run this again and see what happens. This way you can make sure that every single record which you have returned back is correct and not false. And this is a very good way, a very simple way to check it. And we will know that in a second when the tests are running. And if the test passes, we have implemented a correct get all records. If not, we screwed something up. And as you can see, the test has passed. So we know that this particular method has been implemented perfectly, and we don't have to worry about getting the application up and testing it manually. So this is it for the first method. In the next video, we will be talking about get book by ID, where we write this method and also create book record, a little bit of it. And thank you for watching. I'll see you in the next video. So let's get into it. In the previous video, we had written our first unit test, which was a get all record success, where we understood how when and then return works by Mockito. How do we do a request builder and set up our get mock request, and we also see what to expect back when we do an expect from our application. In this video, we will write the unit test for get book by ID and see how that works out for us. And let's get started. Let's see how we can write it for ourselves and see how this is going to go out. We do @test, same old. We do a public void get book by ID, and again it's going to be a success throws exception. And now let's see how do we do this. So now, instead of doing it that way, let's do it another way of implementing this. Let's directly start with a Mockito method. So Mockito.when, and the method call is going to be book repository dot find by ID, and the ID is basically going to be record one dot get book ID. Now, once this is done, when is done, we do a then return, and we are returning an optional book. So a simple way to return an optional book would be to directly wrap the record into an optional. So the way to do that is Java util optional of record1, and that way mocked our we have mocked this particular stub where we have mocked book repository find by id book id get. And now we will always get the record1 as the return value whenever we call this inside this particular test method. The next thing which we do, as we know, is pretty straightforward. We have our request matcher. I'll quickly swim through this so that we can save up on time. And it is pretty straightforward and similar to how it was, so we don't have to worry about it. As you can see, we do a mock request builder to get slash book slash one, because one is the book ID for this. We application JSON status is okay. We do another check here. Instead of checking the size, we can just check whether this is not null, so that it has something inside. The JSON has something inside it that tells us that it was not null. And the next thing would be to check the name, and the name should be atomic habits because that is the first record, atomic habits, and that way we should automatically know whether the test passed or not. Pretty straightforward, nothing complicated here, very straightforward to the point. And let's quickly run the test and make sure that both the tests are running properly. So yep, as you can see, this one also ran perfectly because we intended it to be running successfully. So we had mocked the find by ID, we performed a get request emulator, and we expected the response as we wanted it. So these were successful, and now let's actually write the tougher ones, which are kind of tough to write, not exactly tough, but a bit convoluted for create book record. So let's see how this is going to look like. We do a test public void create record success. Now this is an interesting test because first we need to create a book record. The second thing would be to mock save, which is basically save method, and then we want to, when we do a post, we want to make sure that the content is in the form of a string, and then we perform our request. So a bit but we will make this code, we'll modularize this code to make sure that we understand everything that is happening inside it. So let's start. First, let's create a record to post. Okay, so we'll do a book record equal to book dot builder class, and we can use the builder class for a lot of things. So first let's do book ID, which is going to be 4L. Next is going to be the name, and let's say the name is introduction to C. Next is the summary. The summary is going to be the name but longer. And next is going to be rating 5, obviously, dot build. And this way we have a record which we can post now. Next thing would be to mock our repository method, which is save. So let's quickly mock it. So mockito dot when, and what do we do here? So when book repository dot save, and we are saving our record, then return the same exact record. And pretty simple, pretty straightforward mocking scenario here. Next, instead of writing our request builder here, let's actually write this separately and then do a perform. So what do we do here? What I mean by that? So what we are going to do here is we are going to build a mock HTTP servlet request builder. So mock HTTP servlet request builder, which is going to be a mock post request, and this request is going to have mock MVC request builders dot post. So they have everything handy for post, and we are posting to slash book. Pretty straightforward. The content type is going to be media type application JSON, right? The next thing is going to be what we accept. So once we do a post request, we are returning back a JSON to the client as well, right? Because if you see here, once we create a book record, we are returning back a book exactly as we are returning back a JSON here. So we are accepting media type as application JSON. The next thing that we are doing is passing the content or the request body basically. So the content is going to be, well, content, and that we need to actually implement. So we can't directly pass a Java object, a Pojo, plain old Java object to the content, right? It has to be converted to a JSON. Here, this was handled by Spring Boot for us, but with these annotations. But here we need to manually address that. So for that reason, we have the object mapper and writer here. So how we quickly do this is we do string content, which is going to be object writer dot write value as string, and the value which you want to be written as string is record. Now this will convert the plain old Java object to a string, and then we pass the content inside here. And now we have a mock request ready to be sent. Now the next part is similar to performing that post request, right? So how do we perform the post request? We do a mock MVC dot perform, and what are we performing? The mock request that we just implemented. The next thing would be to expect what when we perform a post request. We do an and expect. This is going to be boilerplate. So status dot is okay to make sure that it was successful. Second is and expect the JSON part to be null. So we can copy this from here, and we can also copy this from here. So let's copy it out and let's quickly paste them. The only change here would be the name. So the name has changed to introduction to C. This also needs to be introduction to C. And this is how we write a post request. So we will go through this again, but let's quickly first run the test to make sure that the implementation is correct. And then we can talk about what did we actually learn in this particular video. So far so good. We have the information and the test has also passed. Great. Let's see the logs. Okay. So here, as you can see, we are doing a post request. We see that we are reading an application JSON, and for this particular string, and we see what's supported by. We are writing or doing a post. We get back to 100, and we then evaluate the path of the JSON. So here we did not go through this approach because we wanted to abstract out or make our code look better and more readable. So first we created a book record using the builder method inside our record. So if you go inside book, you see the builder annotation that helps us create an object quickly using the builder method. Next would be the mock it over when and then, which we have talked about in the previous video as well, where we make sure that whenever we mock an object, we return back when we mock a class and method, we return back the object. Next thing, as we are doing a post request, we need to send the request body in the form of a string, and we achieve that using an object writer. And finally, we create our mock request and then perform the request and expect the values back. So let's quickly run all of them again, just to make sure that nothing has, we didn't break anything, because each test has to be independent of itself. It should not be stateful, because they're unit tests. It should be the smallest unit which you can test, and they should never ever interact with each other. So as you can see, all the three of the tests pass. None of them have anything in common other than the controller which you are testing. And this is how we write our test for the create book record method. The next would be the update book record method, which will be similar to create, but we'll see how that works out. So thank you for watching, and I'll see you in the next video. In the previous videos, we talked about what testing is, what unit testing is, why is testing important in the software development lifecycle. We also created and implemented our own REST API, which was a book controller API, and we also wrote a few tests for our methods inside our controller. We wrote tests for get all records success, get book ID success, create record success, and now in this video we will be writing the code for the update or the put API. And then in the next video and the final video, we will be writing a slash delete endpoint using the test driven development method, where we first write the test and then we implement the delete endpoint for our application. And as you can see, we have tested out every single endpoint, whether it's working properly or not, based on just our tests, and we did not have any Tomcat web server running, or we didn't have to even run the application to understand whether our code is functioning properly or not. And that is majorly the power of unit tests, where these confirm the usage and the implementation of your code, and it ensures that the code which you're writing is implemented correctly. So yeah, pretty important, and you should be doing this whenever you write code which is used by organization. So before we start writing our unit test for the put API, let's just run the tests and see that everything is running smoothly. And we have only two more tests left to write. One is the update test, and the last one, which is going to be done via TDD, is the delete endpoint. So let's quickly see that everything is running smoothly. We should be good to go. So everything is going on perfectly. All the tests have passed, and let's start with our put API. So for this, it is going to be how we want put to be, right? So we want to update a book record. So for that, first we have to mock two things here. So if you go inside book controller and see update book record, we are calling the book repository twice. First, to find the existing book record by the ID, so the one which you want to change, and then we update it with the record which we pass in the request body. And then we call book repository again with a dot save method. So here, since we're using an external service twice, we'll have to mock both the methods find by ID and save. So when we mock both, then we are actually able to emulate or mock the entire repository and see whether the update is working properly or not, and the logic of it. So let's do that. Let's actually see this in action. We have our test annotation: public void update book record success, close exception, and let's start with it. So first we need to have an updated record, right, which will be in our request body. So we need to have a book record which is already updated. So let's have a book updated record, and we use the same builder class for this. We use builder and dot, the book ID has to say the same. The next is the name. So the name is going to be changed to, let's say, updated book name. Next thing is summary. The summary is going to be updated summary, and lastly the rating is going to be 1 dot build. And now we have an updated book record. So first we find the record for 1L, so we need to mock that, and then we update it with the updated book object. So let's see how that is going to happen. So we want to mock things, right? So first thing which we need to mock is find by ID. So let's mock that first. So mockito dot when book repository dot find by ID, and this is going to be record 1 dot get book ID. So whenever it finds the record 1L or 1, then we return record 1, right? So that is basically what we did for get book by ID, and we were good to go. Now the next thing that we need to do is mock the next part, which is mocking the save method inside book repository. So let's copy this exactly, and here we do a save, and when we save, we want to update it with the new updated record. So we do updated record, and here then we return updated record again. So this will tell us that we have updated the record properly and we are good to go in this context. So let's quickly make the syntax look good. And yeah, so now whenever it goes inside the put, it first will go into this, check whether the book exists or not, and this is the logic which we are testing by unit tests. This will work because it is not null. Then we mock find by id, so we get back record 1, which is the existing hard-coded record which is mentioned globally. Next, we test unit test the logic here, and it is present, so we don't get a not found, and we go in here. This part is handled by us, where we update the record, and then when we go to save, this is where we again mock it, and we just return back the existing book record, which confirms that our test is working properly without any issues. So what is next? Next is to again create a mock request. So before that, we have to get our content again. So let's quickly have our content defined, and here the content is going to be the updated record, and we can just call this updated content because it helps understand what it means. So we have updated content here, and the next thing would be to have build a mock request builder, right? So let's implement that. So we want a mock http servlet request builder, which is be a mock request, and this is going to be mock MVC request builder dot put. So we want to test put, and we want to test it for /book. The next thing is the content type which we want to accept. So it is going to be media application JSON. We accept the same thing, so media application JSON again. And last but not the least is the content which we pass, which is the updated request body, and this is going to be updated content. So now we have our mock request ready, and the last thing is pretty similar, pretty straightforward to what we had done for the post request, where we do mock MVC dot perform, and we perform the mock request. And once we perform the mock request, we expect something. The first thing which we expect is status to be okay. The next thing which we expect is that we should be returned something from it. So this is going to be JSON path, which will include the entirety of the JSON, and it should be not null. This ensures that we did get back something from our request. And the last thing is to check whether the name has been updated or not. So here we do a JSON path dollar dot name. There's only one ID here, and we do is, and we match the value updated book name, and this will confirm that yeah, so we went from record 1, and the name in record 1 was Atomic Habits, and then we are returning it back as updated book name here. So that is what we want to confirm, that our put worked perfectly, and it has given us exactly what we needed from it. So let's run this and see how this works. So the test has passed. That means our API, all of our create, update, and get, retrieve APIs are working properly for the ideal input that it gets, or the ideal parameters. Now we have done this for the success cases, right? But the homework here, which I would like you guys to try, is to try this for the not found exception. For example, what happens when you do a get by ID and you give it a random book ID which is not present in the database, and then what happens? How do you handle a not found exception? Because here, if I would not give it as um, the book ID, but I would give it as 4L, which is technically not present inside our in memory objects. So here this would fail, and we want to make sure that we also cover the cases where what happens when the method fails, and when the code crashes, are we handling that or not? So the homework would be to try to have a test which handles not found exceptions, because as you can see, we get a test fail here. So we need to handle those conditions in our unit tests as well. And that is the homework for you guys, where you need to understand how to write them, and we can definitely talk about them once you have given a solution in the comments. Make sure that you have a test class like this, a test method like this, and you have it a get book by id underscore 404 not found, or just not found, and implement this and let me know how it looks like, and then we can discuss it as a new video. So that's it for this video. We have covered how to actually write unit tests for our APIs. In the next and the final video, we will be writing the delete endpoint first by writing the unit test for it, and then we move on to actually implementing the delete endpoint. So thank you for watching. I'll see you in the next video. Welcome to the final video of our playlist, where we write unit tests using JUnit for our Spring Boot REST API application. Now, in the previous videos, we have learned about how to write unit tests for our pre-written API methods, get all book records, get book ID, create book record, update book record, and so on and so forth. But we had left out writing the delete endpoint using the TDD method, which is the test driven development method. So in this video, we will be writing or implementing our delete endpoint using unit tests, which we write first, and then we implement our delete endpoint. So this is going to be a very basic TDD implementation, which will give you an idea of how it works, and then your homework would be to add in the not found exception edge cases to the method using test driven development. So without further ado, let's actually start implementing it. So first, to implement this, we need to have a test. So a test which is going to be public void delete book by id, and this is going to be a success test. So this is going to work to get our basic delete up and running and working. So it should just delete our book, and that's it. So we are going to be deleting by id. So the first thing that we need to do is we need to use the book repository to call find by id, right? We need to get the book first, and then we delete it. So let's do that first. Let's actually mock our book repository find by id method, so that we know that whenever we call find by id in our actual implementation, it will be mocked. So we do mockito dot when, and here book repository dot find by id, and let's do record 2 because we haven't done that in a long time, and then return optional of record 2. So when we query the query for the second book, we get it back, and once we get it back, all our delete endpoint is going to do is delete it, right? We are not going to return back what we deleted, but what we can do is just send a 200 status that yeah, what we the delete worked. So that is what we'll be testing with our simple success test case, where once we delete the book from the database, we get a simple status code as status is okay. So that is what our test is going to look like. So we do mock mvc dot perform, and here we can do a simple mock request builders, and under this we can do dot delete content type also. So let's quickly do that, dot delete, and will be slash book slash 2 because it's the second record that we're deleting. The second thing that we will be doing is the content type. So let me quickly go and do content type, and this is going to be media type application JSON. And as you can notice here, when we write this, we already know that the way we implement our delete book method or endpoint is by having a path variable, right? As we have for get book by ID. So similar path variable and no request body will be there in our application. So this is something which we understand as we write our uh, test cases. So now that we have our uh, perform and request builder ready, we just have to expect one thing, which is that the status is okay, and that is all that we need for a simple delete book by ID success test case unit test. So now in this test driven development approach, we have written our test, and in theory this test should function well in order for our delete API to function well. So let's run this, and obviously it will fail because there is no such API here, and that is exactly what we want. We should always predict the behavior of our code with the test, that is test driven. So here we will know that the test will fail, and for the exact reasons why we want it to. So we wait for it, and as you can see, we wanted the status code as 200, but we got a 405, which is not what we wanted. So now we know what to do. Now what we do is we head to the book controller, and here we start implementing our code. So let's start. This is going to be a delete mapping, and the mapping will have a value which is going to be the book ID, and this is going to be in strings. So let me quickly make them in strings, and public void delete book by ID, and this will have a path variable because that is how we are approaching our method, and this will have a variable book ID as specified above, and this is going to be a long book ID. This throws a not found exception. So we will deal with the not found exception later, but for now let's just implement our method. So now we check the book repository first. We do a find by ID, book ID dot is present, and if it is not present, when we throw new not found exception, book ID book ID not present. A simple friendly message that the book is not present. And the next thing that we need to do is just delete the book from book repository. So book repository dot delete, and delete by ID is what we are going for, and we give it the book ID and we are good to go. So now we understand that it just took me 2 minutes to implement my method because I already knew what I was looking for and what I was looking for in terms of the idea of how to implement it, because I already had my test ready. I already have my test ready, and I have written some code. If I would not be using unit tests, the way I would test this code would be to run my entire application and then create a book. Then I delete the book, I check the database whether it's deleted or not, or I can just run this test again, and this will automatically tell me whether my method which I just implemented is correct or not. And that is the main reason why we want to write unit tests and follow test driven development, because we don't it makes it very easy to understand how our code is functioning and behaving. And as you can see, we have passed our test that automatically tells me that the code which we have written for our delete endpoint is working, and then we can remove this to do and we are good to go. So this is how easy it gets with test driven development, because we now exactly know how our code is behaving and how it should behave, because we have written a test for how it should behave. We know that it should behave in a specific way, where if it's going for record 2, it should delete record 2, and the same thing would be for record 1. So if I do this as 1, I change this as 1 and also this as 1, it will delete record 1, and we can test that again. And you can see how easy it is to actually
update your test and change them and understand how your code is functioning as you do it. Now, another way to do this or to see what's happening behind the scenes is to run this in debug mode with a breakpoint. So once the test is running, we'll see how that is working. So now I want to know what is happening behind the scenes, right? So I can just put a breakpoint. I can run it in debug mode, and when it comes here, we will break the code and we will see what's happening behind the scenes. So the test is running, and once we reach line 138, the execution will stop. And yeah, as you can see, now we can see the data behind our application. So mock MVC is what we were using. And when you see inside mock MVC, we see the servlet context, we see what we have, we see the dispatcher which we are using, the default dispatcher, and what is inside it, the value, or what kind of logs it does, all of that. So you can see the servlet as it's using the different kind of mappers. We also can see what we have here. So we have records, book ID, etc., etc. Then when we continue running it, we see that the tests have passed. So this is how we implement a delete API using test-driven development, where we first write the test and then we implement the logic behind the test. Now, a couple of things that would be the homework would be these. So the first thing which I would like to do is I want you guys to add this in the comments, where you do get book by ID and we do not found. So how would you implement this? This test is what we would like to know. The next test would be something like not found for a delete. So public void delete book by ID not found. And what happens when you give it a record as 70 as the book ID, and we try to delete 70, but 70 book ID does not exist in the database? So how do you handle that test case? Will the code break or not? So we handle that, and we want to know exactly how the code is working. So that is basically what we do with our negative test. So this is a positive test where we know what is going to happen, it's going to be successful. These are negative tests which tell us when we have control over what happens when the code breaks. So this was the playlist about how we can write unit tests for our Spring Boot REST API application. I hope this was helpful. If you have any doubts, please mention them in the comments below. And thank you for watching. I'll see you in the next playlist.